Good afternoon, everyone. My name is Raman Bedi, and today's topic is big data and Hadoop. So, in today's modern age, today's digital era, we have so much of digital data going around. Your blogs, Facebook posts, Twitter, and your wearables, mobile phones, emails. So much of digital data, so much of big data. So, again and again, I am repeating this term of big data. Let's see what big data really is. So big data basically is colossal amounts of data, colossal amounts of digital data, which can be analyzed to find some kind of pattern, according to which we have to make some sense out of that data. Obviously, this data has to be useful. So to make that sense out of the data, and if that data cannot be handled by traditional RDBMS, we classify it as big data. Now, you can see an infographic here about 2014 February stats of WhatsApp. There were 450 million users of WhatsApp in the year 2014 for the month of February, and there were 1 million new WhatsApp users joining each day. 1 million at that time. Now the number has increased, and at that time only, the number of WhatsApp messages had far superseded the messages on SMS. 50 billion was the amount of messages on WhatsApp, and only 21 billion was the amount of messages. That's more than double. Compared to global SMSs, WhatsApp was far ahead, and now that number has increased. Now let's come on to the principles of big data. So big data has 4 V's principle. These 4 V's are volume, its velocity, its variety, and its veracity. So let's look at each one of them in detail. Now let's come to volume. Has anybody of you heard about what a black box is? What's a black box? Can anybody raise their hand? I would remind you about a Germanwings crash that happened, and something related to black box. Yeah.
It's एक aeroplanes वगैरह में रहती हैं कि data store करती है flight location and their cockpits all.
Yeah, you're totally right, and you have won a 5-star for that. So there are goodies to be won. Okay. So yeah, he's absolutely right. Big data stores all the data of the flight, and from each engine, the data is stored into the black box. So I would try to tell the volume of this data. How much data does a flight contain? For one engine of Boeing 737, it contains about 10 TBs of data for an half-an-hour flight. So a Boeing 737 flight going from Delhi to London on a 6-hour route, and a Boeing 737 has 2 engines, it would amount to 240 TBs of data in just one flight. That's a huge amount of data, and obviously that cannot be processed using a traditional RDBMS. We would require some big data tools for that. So volume is one of the V's. So every time we hear about big data, it's always about the volume. How much amount of data do you have? But it's not only about just the volume. It's about other V's as well. So let's come to the second V, and that's about velocity. For velocity, velocity just means the rate at which the data is increasing, and how much big data do we have. So for that example, let's take the example of Facebook. Facebook in 2011 used to generate about 15 TBs of data each day, and now that data has increased exponentially to 500 TBs a day. So that's a huge, that's an exponential increase in the amount of data being generated each day by Facebook. So they obviously require some big data tools to analyze this data and make meaning out of that data. Now let's come on to the third point about variety. So how does variety exist in big data? So variety is about where the data is stored. Now we have our data on our CD drives, we have data on DVD drives, we have data on your mobiles, your hard disk drives, your SSDs, everywhere data is available. And this data can be available in form of text files, flat files, CSV files, your databases. So all this data is available and we have to process each and every kind of data. So this data has three classifications for the three categories. These categories are structured, semi-structured and unstructured. Okay, now can anyone tell me or anyone guess what would structured data mean? Okay, what is structured data? Yeah, you're totally right, and there's a gem for you. Okay. So structured data is basically the data that has a schema. Your RDBMSs are a major example of that. So this data can be processed in big data, and it's a kind of variety. Second kind of data is semi-structured. This semi-structured data has some pattern on which we can just take out the data, meaningful data out of it, like logs. Your email logs or call logs. If I take the example of a call log, the logs can tell me from which number the phone call was made and to which number the phone call was made. So I can just apply a regular expression and take out the data that is useful for me, like from which number was it made and to which number was it made. So this is semi-structured data. Now let's come on to the point of unstructured data. What can be unstructured data? Okay.
What's the message is unstructured data?
Actually,
text, video, audio, video, file, or data.
so you are absolutely right. And so what would you be getting? Let's take out a dairy milk, please pass it on. So all the videos, audios, like if I have to do face recognition on an image and scale that images to the amount of Facebook images, that's a huge amount of data that we are talking about. And obviously this is the part of variety in big data. Now let's come to the point of veracity. Veracity is basically the ambiguity or the uncertainty in data. Like the data is not correct. People collect data, and you also know about organizations collecting some data. But this data is not 100% correct. Obviously, according to this infographic, 1 in 3 business leaders in the US are not sure whether their data is correct or not. The US economy every year loses about $3.1 trillion due to bad data that's been collected. So that's a huge loss that's happening. And it's a point that we have to give value to the data, and value and veracity come as the fourth V in the 4 principles of big data. So now let's move on to the next slide. I would be comparing the traditional BI with big data solutions. So the traditional BI solutions, what did they consist of? They had a central server or data warehouse in which all the analysis used to go on, and for that all the data of your systems were transferred to that central data warehouse, and this much of data being transferred used to choke the bandwidths, and it's a huge amount of data that goes into the central warehouse and where the analysis takes place. And the central warehouse, it basically consists of blade servers like 32 GBs of RAM and like Xeon processors and everything. They are highly costly, plus they are actually vertically scaled. Vertically scaled means that you have one server and it has a massive configuration. It's a very good configuration. So that used to happen in case of BI. Now in case of big data, all the data is stored on nodes, and if you want to add some more data, you can add some more nodes. So this is horizontal scaling of data, that we have separate nodes and on each node we have some data. Now if we have to do some analysis on this data, just think about it, we have to do some analysis on this amount of data. What would happen is that we would just transfer the logic over the wire. So there is no choking of bandwidth because the data is already present on the nodes. Your 100 nodes cluster, the data is just present there. You have to just transfer the logic over the wire, that what has to be done with that data, and that thing can be extracted out. And the second point is about horizontal scaling, that these servers require just a normal CPU. Even the CPUs that we use for our normal purposes can be used in the cluster, and that is much more cost efficient. So this was about the comparison of big data versus traditional BI. And further, I will be passing on the presentation to Kanav.
Thank you, Raman. It was very nicely presented by you. Very warm good afternoon to all. I am Kanav Narula and I'll be taking it forward from here. And we'll be discussing what are the big data opportunities, what are the challenges being faced in the organization today, and then we'll move forward to what is Hadoop. So what are the big data business opportunities? So if I talk about today is a data age. So what are the challenges being faced by organization if they want to implement big data? We have seen 4 V's. So if they want to implement big data, what are the aspects they have to keep? First is we have an exponential data growth. Like we have seen an example in Facebook. In 2011 it was 15 TB data and they were using MySQL servers for storage. Now in 2015 it's 500 TB data and they are using HDFS, that is Hadoop distributed file system. So you can see a growth, exponential data growth. In just 4 years, data has increased from 15 TB to 500 TB. That is the amount of data. Second is complex data analysis. We have, before we have only structured data, that is static schema. Now we have semi-structured data, unstructured data. Unstructured data can be an image, like Facebook is processing an image. A video I want to process, that comes under unstructured data. Real-time insights with dashboards. We are living in an age where horizontal scaling is there. So there are so many servers to maintain. So we need one dashboard where we can see how many servers are up, how many are down. Tighter budgets with the need to do more. Organizations don't want to spend more money on the server, on the infrastructure. So budgets are tighter. Predictive analysis. They want to predict what is going to happen in next 6 months. Like every system stores syslog. Everyone might have heard about syslog. It stores like CPU utilization, memory utilization, disk utilization for every desktop. So if I take a syslog and I want, and let's take an example. Daily I'm running one job in my system and it takes some CPU utilization and memory utilization. So if a job is running at night, so utilization will be high at night. So I want to compare what is the utilization. I'll check the logs, syslog, and I want to see what will be the utilization in the next 6 months. So I'll apply predictive analysis using different tools. Next. So these are some of the big data products. First is Teradata. It's a relational database. It supports both analytical processing as well as transactional processing. Analytic, we have seen like a data warehouse, data kept in a data warehouse. We can process their data in an offline mode. If I want it in real time, it supports OLTP, that is transactional, bank details. Second is Hadoop. It's an open source. It supports OLAP. We have 2 versions of Hadoop, 1.0 and 2.0. The earlier version only supports OLAP, and second, the newer version supports both OLAP as well as OLTP. Netezza, DataStax, Plum are the other big data products in the category of big data. Next is Hadoop. So before going to Hadoop, like just to make sure that everyone is awake, we'll have some questionnaire round. Just tell me, can Hadoop process analog data? Just raise your hand.
Yes. Yes. Yes.
Okay. Okay. Any other? All
No.
yeses? No, it can't process. Who said no? So Hadoop can't process. You said. Right. So Hadoop can't process analog data. Means analog data means data present in books. Hadoop can't process it. Minimum requirement is it requires digital data. Just tell me another question. What is the amount of data Facebook is storing today? Just the amount.
500 TB. 500 TB. Okay.
So nobody gets a job.
Yes. You just have to raise your hand. Nobody gets the chocolate. What is the amount of data being stored in 2011 by Facebook?
3 TB.
Very. How much?
Just pass it to Dilkush. Just for raising the hand, okay? Okay. How much amount of data is being generated by an airplane for 1 hour flight?
140 times. 1
Okay.
hour.
1 hour.
It was for 6 hours divided by 640.
Okay. Any other guesses?
30.
Okay.
40.
So answer is 20 TB. For every half an hour flight, half an hour route, it generates 10 TB of data. So 1 hour, it generates 20 TB. James, sorry. Raman, we are short of James now. I think we should stop asking questions. Oh, yeah, we have one. Let's take it forward. Let's see what is Hadoop. So I'll read a definition here. Apache Hadoop. It's a product of Apache. It's been developed by Doug Cutting in 2007. It was developed in 2007. He was working on some nuts project. So he got motivated from a GFS Google file system paper. So he started developing this Hadoop. So Apache Hadoop is a framework that allows for distributed processing of large data sets across commodity hardware using a simple programming model. So there are some keywords to be noted, taken from this definition. First is, it's a framework. It's a complete framework that does storage as well as processing. It's not a processing engine. It's not only a storage. It's not a data store. It's a framework which does both storage as well as processing. And for storage, it uses HDFS, Hadoop Distributed File System. Second is distributed processing. So we have a concept of DFS, Distributed File Processing. So what is DFS? Everyone is aware of DFS? So why today every file system is based on DFS? Let's take an example. Just suppose we have one system of 10 TB hard disk, one system 10 TB hard disk, and it has 4 input output disks, means 4 hard disks to read. Per hard disk can read 100 MB per second, means reading and writing speed is 100 MB per second. I want to read 1 TB of data. I want to read 1 TB of data, just want to copy 1 TB of data in this system with 4 hard disks, and each hard disk can read 100 MB per second. So how much time it will take to copy 1 TB of data into this system? Any guesses? You can use your notepad for calculation.
1000 seconds.
How?
So 100 Mbps, 10 seconds is GB.
Okay.
And multiplied by 100, so 1 TB in 1 TB in 1000 seconds. And if we calculate 24 seconds, then it can be above 24 MB.
So I tell you 1 TB equal to 1024 GB and 1 GB equal to 1024 MB. Now you can calculate how much time it will take to read 1 TB of data.
It will be around between 20 to 60 minutes.
Okay. That's a huge amount. Huge number. Any other guesses? So time taken will be, we want to read 1 TB. Let's convert it into MBs. 1024 into 1024 divided by 400. So this will give us the time into 60 will give us the time in, right. So it will take 45 minutes to read 1 TB of data. So now just understand, it is taking to read 1 TB of data, it is taking 45 minutes. And Facebook is generating 500 TB of data. Just multiply 45 into 500. So all the time is going in just the storage, no processing. If we are using traditional systems, the on time complete day is going in storage, no processing. Let's take another example. Instead of one system, now I have 10 systems. And data getting stored, that is 1 TB data getting stored in 10 systems parallelly. If we are using 10 systems, how much time it will take? Yes, obviously 110. So 4.5 minutes. So this can be considered. 4.5 minutes can be considered instead of 45 minutes. So this is the concept of DFS, that is data gets distributed into different nodes. By node I mean desktop machines. So data gets distributed and it takes less time to read. This is called horizontal scaling. DFS means distributed processing, or we can say horizontal scaling, adding number of nodes. Instead of one we can use 10 machines. So this is the meaning of distributed processing. Everyone clear? So it's a framework that allows for distributed processing of large data sets across clusters of commodity computers. We don't need high-end servers like Blade, RAD, SATA devices. We only need commodity hardware, that is inexpensive material, inexpensive computers. Like we can use our 4 GB or 2 GB desktops to run Hadoop cluster. Means a network, we can develop a network. So we need inexpensive systems using a simple programming model. So it uses a programming model. The engine name is MapReduce. MapReduce. Companies using Hadoop. Frontor. Are you sure? Frontor is using Hadoop. I thought it's the first session for big data. Other companies are Facebook, Amazon, Yahoo, IBM. What are the characteristics? So it's open source, easily available. You can copy the source file, you can enhance it. So it's open source, highly scalable, that is horizontally scalable. You can add as many nodes, and that node doesn't have to be homogeneous. Means we don't need similar configuration machine. One can be a 2 GB, another can be a 4 GB. So heterogeneous scalability. Reliability provided through replication. That is, data redundancy is there, one factor is there, but a replication concept is there. Suppose I want to copy a 100 MB file, so it will be copied to 3 systems. Just to make sure, if I want, in cases like if I want to take a maintenance, so data is available from other machine. Or in case of shutdown or some other crash, so still data should be available. So this is the meaning of reliability. Economical, because we are using commodity hardware. Next. Just get back. So this is the logo of Hadoop. This name is being given by Doug Cutting. It's a toy, elephant toy that his son was using at that time in 2011. So he gave a name Hadoop on the same. Next. So as we know that, I think overview of Hadoop is clear. Ki what is Hadoop? It's a framework for distributed processing, which does storage as well as processing both. So every operating system is based on block size. Whether we are storing data in Windows, whether we are storing it in Linux, any flavor of Linux, or any file system, it is based on block size. Like in Linux, any flavor, it is 500 bytes. If I want to store a data in Linux, block size is 512 bytes. Similarly, in Hadoop, it is 64 MB by default. 64 MB by default in Hadoop. So, concept of block size is, suppose I want to read a 100 MB file, how to store that 100 MB file? That depends on the block size. So, if 64 MB is the block, it gets split into 2 parts. For fast writing and to read it fastly, it is based on block size. So this is the Apache Hadoop ecosystem. So we have this Apache community started this Hadoop ecosystem. They have developed so many utilities like Flume, Scoop, Zookeeper, Uzi, HBase, so many of them. What was the reason to start this Hadoop ecosystem? Hadoop was written in Java, and everyone was not comfortable with Java. So every logic has to be written in Java when in starting 2011, and everyone was not comfortable. So Apache community in 2011 started developing utilities so that people don't have to write the logic in Java. They can write it in Python, Ruby, or they can use big Hive utilities or HBase to write their own code. So this was the reason this Apache Hadoop ecosystem came. So let's start with Scoop and Flume. You can see it on your right, your left and my right. Flume and Scoop. So Scoop is a utility. I'll give you an overview of each and every. So Scoop is a utility for data exchange. Data exchange between relational databases and HDFS. HDFS means Hadoop Distributed File System. The file system Hadoop is using is HDFS, Hadoop Distributed File System. So Scoop is used for data exchange between relational databases and HDFS, or from HDFS to relational database. It means import and export. Only the structured data, because RDBMS contains structured data, not unstructured data. Flume is used for semi-structured as well as unstructured data. Import and export, semi-structured and unstructured. Flume is used, and Scoop is used for structured data. Third is a Zookeeper. It's a service, monitoring service, provision services, synchronization service. So all these features are provided by Zookeeper. It's a coordination service which provides access to the data, and it monitors which system is up and how much data that particular system contains. So that is being provided by Zookeeper. Uzi, it's a workflow scheduler. Example can be like in Linux, everyone, like if you want to schedule a job in Linux, you are using cron tab. Just to automate the job, it should run every 2 hours. So you are using cron tab. Similarly, we have Uzi, workflow scheduler, where you can schedule your jobs. You can tell if this job should run at 2 o'clock, this job should run at 4 o'clock. Or if there is a dependency between the 2 jobs, like if first job completes, then only the second job will run. You can do the same in Uzi. These all are the Apache products. Clear till here, or you want me to repeat? Clear? Fourth is Pig. It's a scripting language where you can write your logic. It's simple English. Suppose you want to write, you want to load a file into HDFS. You will simply write load, name of the file. You want to filter something, you'll use filter and the keyword. So simple English, you can use it in Pig. It's a scripting language, and the engine they are using is Pig Latin. Like for Hadoop it is MapReduce, for Pig it is Pig Latin engine. Another is, let's go to Hive directly. Hive, it's a query language which is similar to SQL. So the queries we are writing in MySQL, Postgres, SQL, structured query language, you can write the same in Hive. The engine they are using is HQL, Hive query language.
Suppose you still querying the data in HDFS using Hive?
We are not using that.
So generally?
Yes.
So when using Hive, you are still querying the data that's there in HDFS.
We can.
So if I have to write a query, query is generally for structured data, like a tabular format. So does it assume that your data that you're storing on the file system, that is also in a tabular?
Hive is structured, like it provides a static schema. You have to define, it's similar to RDBMS. You will be defining a table schema, and data will be stored in HDFS, but it will be replicated to Hive. So you can query in Hive.
Means when we write query in Hive, we will ask to Scoop.
Scoop is a data exchange utility. So once you have to take data into HDFS, if you want to process something in HDFS, you have to take the data in HDFS. So Scoop is taking the data from relational databases to HDFS.
Okay, it's a transfer.
Yes. Data exchange utility.
Data exchange.
Once data is there, you can use any of the above utilities to work on that. Later, you want to do, you want to write a script, or you want a static schema, you want to apply partitions, indexes similar to RDBMS. Related to that, you can use any of the above utilities.
So basically you are converting some form of data into binary data into ASCII plain files, flat files.
Yes. In Hadoop, everything gets stored in flat files. From there, you can convert it in any form. Like if you are taking it in Hive, that will get converted into a structured form. Clear?
So can you please repeat that question for answers?
So the question was ki, if I want to process something, if I want to query in Hive, do I need data in Hive, or it will query the data in HDFS? So data if I want to process data in Hive, data has to be present in HDFS because the base is HDFS and MapReduce. The base is this. On top of that, we are using these utilities. So the data has to be present in HDFS. If I want to query it in Hive, so Hive is like a structured, it provides a static schema where we'll define the column names, we'll define the rows. On that we can query our data, right?
Like if I'm using Big and writing some scripting and calling the Hive query, that Hive query means asking the HDFS to process the data. Like
All they are integrated, they can communicate with each other.
means I will use Java over here also. I mean I replace Java with Big.
Yes. Java you can use it here, MapReduce, because both of these are written in Java. So MapReduce, where you write your logic in Java.
Then my Java will query Hive. I mean, if I'm directly
Yes,
right.
you can. It's up to you, like whether you want to query HBase, whether you want to query HDFS, whether you want to query Hive. It's up to you. Like you have to define your logic according to that. Which database you want to query from Java. So it's, like configurations are there. If you want to use HBase, we have HTable. If you want to use HDFS, we have text input format. I'm going into more technical. So it's up to you how you want to query.
So here's another question. So once the flat file is stored in HDFS, would it matter if it is one flat file or 1 terabyte of data, or it is 10 different files of smaller divided by 10 configuration? So would it matter? Right?
First of all, like as I said, the data gets stored according to the block size. So 1 TB file will not be stored. Suppose I kept my block size as 512 MB. So 1 terabyte file will be divided into 512 MB chunks. So there will be more number of files to process. And whether it is 10 MB or 10 TB or 1 TB, it doesn't matter to Hive.
So all the data that you are storing, if it's a 10 GB file or a 10 TB file, it would be split into the block size. 64 MB files would be made, and the data would be stored in that way. And then it depends whether you want to store it directly on the HDFS or if you want to store it in Hive, then it would be just the structured format that's stored.
So when you're saying storing in Hive, what does that mean? Is it still HDFS?
It's HDFS.
So Hive manages how it's stored. The
Yeah.
file,
Actually,
structures.
yeah, the people coming from traditional BA were scared to, well, I'm not using the term of scared, but were not convenient in using Pig Latin or Java for doing their work because they had to learn it all. So the Hadoop people gave Hive. It's 99% SQL compliant. You can run your queries and then you're comfortable.
Is there something both of that
Yeah, there is a defined Hive query language and you can go onto the internet and see.
So the question was, is there any dashboard or any kind of tool for using this? Like we have a SQL server, like where we can
Like a
pass
client.
on the client.
Okay.
You can have a dashboard on top, but as of now, this Hadoop framework is not providing. But you can integrate Ambari, Zabbix,
Third-party solutions.
third-party tools. You can integrate with these utilities.
Is there also ODBC driver? This or JDBC driver?
There's a JDBC driver present.
This high part is clear. So we can move forward with this R connectors. R connectors are being used for doing predictive analysis. Like we have seen, if I want to predict what will happen, how much my utilization, CPU, memory utilization will be there in next 6 months, I can use this R connectors. Okay. These are the utilities present on the data you can use. Mahout, it's a scalable machine learning language. It has its own algorithms. So example, I'll take an example. Suppose you go on Amazon site and you are looking for a tab. So once you buy a tab, next time when you go on Amazon, it automatically gives you saying these are the tabs available. So that can be done using Mahout. Means it learns from the history of your buying in case of Amazon, and it tells you what you'll buy next. Suppose you are buying a mobile, so it can make an estimate that you will buy a cover also for a mobile. So it can tell you different covers available for that particular mobile. So that is being done using Mahout. On top of that, we have Ambari for dashboards. We can have Zabbix. There are some other utilities also available. So for monitoring, provisioning, synchronizing, we can use Ambari. The last one is HBase. It's a columnar database. So the people who are moving from this relational databases, they can move directly to HBase also. It stores data in columns. For fast querying, we can use HBase. So any questions in this Hadoop ecosystem?
In how you said it is used for predictive analysis.
R connectors are used for predictive analysis.
And I want to ask, like, if, do we define any predictions in this database? Like you said, when we are going to buy any mobile, then Amazon will give us options to select cover also. So we need to define it somewhere, like if the customer is searching for mobile.
Like in Amazon case, they are using your history. We need historical data from which that algorithm can run. So we need to feed some 6 months or 1 year data from which it can learn how a person will think. So Amazon has a lot of historical data. Like you are not the only one who is buying a mobile. There are so many billions of people who are buying mobile. So it has learned from that history. And they have their own algorithms. We just need to feed the data.
So Mahout is a set of algorithms that do recommendation as well as classifications. So you have the algorithm already made. You just have to feed it data. That's it.
What was the classification?
Like we talk like Chandigarh result. I have a medical store. I will give you 10-year data of some medicine shop. Like Chandigarh has this kind of health issues are like. This Hadoop in this process means what exactly, what are the major concerns in Chandigarh regarding Chandigarh?
What is your question is you want to see a medical history in Chandigarh region.
Other may ask,
He has provided Chandigarh region medical shops, what medicines they are selling, pharmacists and what they are doing. What he is trying to say is, will Mahout help to understand what kind of
medicine
medicines
I
are
will
there?
kept at that store. Maxim means like physical, signal or different columns. So medical store वाला
So we have historical data
like
in
कौन
place.
सी medicine से ज़्यादा
Yes,
sell.
Mahout can help it there. Mahout and Arctic both will come. So Mahout, how Mahout will help is, suppose you have a medical history. So suppose let's take an example, it's a headache. So it can generate a history how many people are having headache and what are the medicines they can take, and from your history which medicine is suitable to you. It can generate a history. It can generate a report related to that. And using R connectors, you can say future prediction. Like as number are growing, you can say if today it's 10 million people who are having headache, as time grows, how many people will be having the same in the next 5 years. You can have.
So related to this thing only, Google has already built a tool. In 2009, Google has this tool called Google Flu. So it detects the earlier activities where influenza is spreading. And in 2009 in US, they told that where the next attack of influenza will be. And there the medical conditions were already prepared when the flu was spread there. And they were totally bang on target. So that's big data analysis for you.
totally we deal with now machine learning.
Yeah, like with machine learning.
Let's show them.
One. There are tools like Spoon, Hive, Architecture, right? And there is MapReduce. So let's say I'm using Hive to fetch all the data, to store all the data structured or SPSS. Okay. So where is MapReduce coming into picture?
For processing at the back end, we have an engine. Suppose you are running a query on Hive.
Okay.
So how it is taking data from different machines. There comes an engine called MapReduce.
So Hive will automatically do the things for me. I don't have to learn Java or anything to write MapReduce.
Yes.
I don't have to write
Yes.
those, right?
In Java, you need to define what your mapper will do, what your reducer will do. Means what the logic actually is. In Hive, you'll just write a query. Select, start from this, where you give a where clause. It will automatically convert into MapReduce, and it will give you the exact data.
And I guess not all problems fit into Hive's domain. Like they said BI, that's one good example of where they use Hive. So, like in your case, maybe you might not be able to use Hive.
Any other questions on this Hadoop ecosystem?
Sir, when we write SQL query in Hive, then it commands the other Hadoop ecosystem parts like OZ Bake to command. It commands others also.
No.
When we write.
Everyone is connected. You can connect, you can integrate all of these. But if you are running a query on Hive, it will not command, like Uzi is for workflow. So Hive doesn't have anything to do with Uzi if you are running a query on Hive. So it will not command, means it will not ask others. It will just fetch the data using MapReduce and will display on the console, or if you want to store it in a file, you can have it in a file. But it will not communicate with others in case if you are running a query on Hive. So this is just like a code snippet how the logs look like. If you see a sys log, these are the email logs taken from this Thunderbird. Many of you would be using Thunderbird. So this is how a logs get created. So you just need to take out some of the keywords. Like this is a semi-structured data. And if I want to store it in Hive or Pig, if I want to store it in Hive, I need to convert it into structured data. So I need to find some keywords. And on top of that keywords, I'll apply functions like substring, replace. These functions I'll apply. So first we need to see a date and time. Second, we need to see delivered to. So there are two keywords in this log, delivered to and transfer to. So delivered to will tell what are the incoming mails. Means from inside to inside, means within Trentor, what are the incoming mails. And second keyword is transfer to. How many were the outgoing mails? Means suppose I have sent one mail to Gmail, so that will become an outgoing mail. So what are things to be seen is first the date and time, second transfer to, in case of transfer, what was the server used. So in between transfer to and for, I have which server was used to send a mail from my Trentor ID to Gmail. Second is who was the one I sent it and to my Gmail ID. So this is how, what was the size used, size of the mail. Does it contain any attachment and what was the size. So it will tell you everything.
This processing is done by MapReduce also.
Yes.
Right? And Hive and other tools are for fetching the data.
You can, yes, for front end you can say it's not actually a front end, but for fetching, for displaying, you are using these utilities. But at the back end, it's a processing engine called MapReduce. Whether it is MongoDB,
logic is there.
yes, everywhere it's a processing engine called MapReduce. So what was the script used to fetch this incoming logs? This is a small script being used. First, load that file. I've loaded it into incoming logs object, filter, and what are the functions I need to use, substring, concat. So on top of that I can apply functions and it will give me a structured data. and I can store it in Hive or CSV. You can store the CSV also. In this way, it will the CSV will appear. To, from, forward is what is the size of the mail, ICID and MID. These are how to connect. Like suppose I have sent one mail, and that mail has been sent to many people. So in case I have sent to 10 people and it has been received by 9, so it will tell if for one mail there was an error. Subject is there, so you can convert that into a structured format using these Hadoop ecosystem utility.
Any other questions?
Would you like to also explain, the kind of work that you did? So any case study, how you were able to
Okay, so I would like to quote an example from our case, Grantor's own big data solution. So we have a social feed and news aggregator that aggregates news, and it's actually called the Big Data Grinder. It's our own product, and what it does is that it fetches news from different sources on the internet, plus it fetches the social feeds from Facebook as well as Twitter, from blogs, and then it analyzes them. It actually does named entity recognition out of them, like what are the places present in this news, what are the names of the people or the organization that are present in this news, and it also finds for keywords. Like you have targeted some keywords, I would be more interested in news for digital marketing, so it just tags that digital marketing is present in this news. And this all data is first fetched, and then it's enriched, and then it's already stored into HDFS. First we were storing it into just the flat files in HDFS and using Scoop to transfer it to our MySQL solution, our RDBMS. Now as our requirement has grown, we have started using HBase, and now we are using HBase in our system, and now we don't require Scoop as well, and that has dramatically reduced the time as well. We are down to 50% of the time right now as well, and we would be improving it.
How much data do you churn?
It's about 5 lakh of records. So that's the amount of data that we get.
So how many nodes are there, and what are the sizes of this node?
Actually, we didn't require a lot of size for the nodes. So the nodes are just commodity hardware consisting of 40 GB disks. But the number of nodes is 8. We have 8 nodes, each of 40 GB. So we have 320 GB of space, and that was our space requirement because we don't store that data too much. But as we have started using HBase, we would be increasing the data because we plan to store it more and do some analysis on the data as well. So that's our solution. Grantor is using Hadoop.
So Gaurav, were you able to see some benefits?
Interesting.
Yeah.
Yes. We are very in process of implementing all fetching all the benefits of it.
So basically, we have new requirement upcoming where we need to find this triggering the solution, getting news approximately near to real time. Right now, we are thinking is fetching news after 24 hours every day. What we are trying to do is user want to see the news within 5-10 minutes. We are providing the news.
Instead of you storing it, they'll be storing it.
Absolutely. Yeah. So approximately near to real time, they will provide us the data, analyze it.
We are planning on it.
You can give another presentation. Once you're
Sure. Any other questions?
You'll get a goodie if you'll ask a good question. It's everything me and Raman have to manage.
Sir, for data security, I have read something about Hadoop that it is a poor data security like.
Okay, talking about the security issues in Hadoop, earlier they were not present in the 0-point versions, but now from 1.x and in 2.0, you have full secure systems, and you can obviously connect your systems over encrypted SSL as well, but that has to be managed. Like that has to be set on by default. It's not on SSL. It's just the normal data that's transferring over your port number 80 over HTTP.
And you can install
over your TCP
Kerberos.
ports.
You can install Kerberos on top of that. That will make your system fully secure.
So how easy,
Raman,
how easy biggest configuration of Hadoop as compared to MySQL or Excel?
It's
just
not
a 7-step configuration. We'll be sharing the manual. 7-step configuration, easy. You just have to configure 2 or 3 properties. Then you have to format the system and just restart it.
And formatting the system means formatting the HDFS.
Just 15 minutes configuration. If you are fully concentrating on the file, just 15 minutes.
Can we make it separate? All steps?
You can make it automated as well.
We have done in our case.
Raman, there is a term, I think it's in use of a lot of people using that, big data table. Can you put some
Big table.
Big table.
So big table was a concept by Google, and as Google file system was there, and from Google file system the idea was taken. That was the original idea, Google file system, and then HDFS was made. Then on top of that, Google, to search such massive amount of data, Google used Bigtable, and a copy of Bigtable is HBase. That's the kind of solution that we are using right now. HBase is basically the replica of Bigtable for open source systems, so that we can use. BigQuery is the query that you can use on top of BigQuery.
You can say that. So Google has given you hosted solutions. You know, you upload all your data to their data centers, and you use SQL-like language, like Hive. So they have like given their own brand, and there must be some optimizations there. And they give you, they allow you to search petabytes of data in a fraction of a second.
And Google provides BigQuery, their Hive is there. Hive plays the role of BigQuery.
So there might be a hybrid of Hive that they might have customized. Hive is open source, so they might have created their own version on top of it. Their own, they customize to their needs.
All the solutions in Hadoop are basically inspired from the Google people,
Right.
and they are available in the market after 2-3 years of what Google has made it. So
Right.
we are actually 2-3 years behind what Google is doing right now in open source. But then also you can get to that scale at which Google is doing its data crunching. You can get it from the open source systems as well.
So they also keep publishing their technical
Yeah.
papers based on which people
People inspire it.
So the algorithms are the same. Just that the implementations they differ. MapReduce was also pioneered over there.
MapReduce was a Google paper. MapReduce was a Google paper, and then
When you search on Google, it applies an algorithm, and that is called MapReduce.
so kindly fill the exit test. Yeah, your question please. So, for processing information on big data, Kanav already discussed some big data solutions. Instead of Hadoop, there is Teradata, there are other Splunk, there are other solutions present as well. But every solution has its own merits and demerits. Like SAP HANA, if you want to just purchase it and install it on a system, you would require a big cluster of servers, and all the servers should be at least blade servers or more than that.
And that
So-
cost 10 crores, 10 crores.
10 crores for one
Other
server.
products are like you need to buy a license, and Hadoop is an open source. So it might be the best solution in terms of cost saving.
So everything has its demerits and merits. There are many major players present in the big data market. Yeah, Bedi is also there, but you can do single level, it's not big data. Processing part.